Hi, welcome back. So in this video, I will show you how to continue with quadratic Newton interpolations. So quadratic Newton interpolation is when you decide to have your n equal to 2. So whenever your n is equal to 2, it is a second order Newton interpolation, or you can simply call it as quadratic Newton interpolations. So this is, I will highlight to you. So this is the general formula for quadratic Newton interpolation, in which you need to be able to find out what is the value for the first divided differences and also the second divided differences. Alright, so because you have more divided differences that you need to find out, so I suggest you to do it in a table form, so it will be easier for you. Right, with that, I show you using example 3 here. So let's say that you're given 3 points. So the first point that you have here is x equal to 0 with your ln 1 equal to 0. So this is the first pair. Second pair is the second coordinate, second value, second point, x1 equal to 4, in which the value of the function is equal to, the value of the function is equal to 1.386294. And then your third point is equal to 6. Your third point is 6. And the value of the functions is 1.791759. Okay, so you know that the function that you're trying to evaluate here is actually, when you look at here, the functions that you're trying to evaluate is actually the ln x. Okay, now you need to use second order polynomial to evaluate ln 3, meaning that you want to find out what is the value when your x is equal to 3. Yeah. Now, it's very easy for you to solve this using tables. So I suggest you to have a column like this one. So you have I, xi, and then your functions, the value of the function. Then next to the value of the functions is the first divided differences. Then we carry on with the second divided differences, xi, xj, and xk. Alright, so for the first iteration, first I, which is I equal to 0. So you have I equal to 0, 1, and 2. So x0 is 1. With the value of the value is 0. Then when x equal to 1, your x1 is 4, and the value is 1.386294. And when your x is equal to 2, your x is 6, and your functions, the value of the function is 1.791759. Okay, let's do the first derivative. No, first divided differences. So the first divided differences is a combination of these two values, okay, involving this one as well. So it's going to be, so the first divided differences is a combination of f, and it is x1, x0. So it's going to be the value for fx1 minus fx0 divided by x1 and x0. So this is going to be, the value here is this one, so it's going to be 1.386294 minus fx0 is 0 divided by the point for x1 is 4, x0 is 1, so it's going to be 4 minus 1. 4 minus 1. And when you solve this, you will get 0.46298. Now let's move on to the first divided differences, but this time around it's going to involve this value here, this one and this one. All right, therefore the points will be 6 and 4. 6 and 4. So I need to come up with this one here. So it's going to be f, and the combination of the point is x2 and x1. So that will be the function for x2 minus function, the value of the function for x1, divided by x2 minus x1. Okay, I hope that you can see the pattern of how to get the divided differences. So fx2 is this one here, 1.791759 minus fx1 is this one. So it's going to be 1.386294 divide by x2 minus x1 is 6 minus 4. So it's going to be 6 minus 4. So once you solve this, you should be able to get 0.2027325. Oh my God, it's more than the boundary. I hope it is okay as long as you follow me. Right. Next thing is you need to find out what is the second divided differences. So this is the second divided differences. So this one here is first divided differences. Please bear with my handwriting. Okay. Now moving on, what we need to find is the second divided differences, which involve this rule. So we'll have this, which involve this value, okay, and this value. Okay, so it's going to be the first divided differences, sorry, the second divided differences. Okay, so what we have is a combination of, at the moment we only have like x2, x1, x1, x0. So it's going to be x2, x1, and x0. Alright, so it will be a combination of the differences between x2, x1, okay, minus f x1, x0 divide by x2 minus x0. Okay, so this is x0 here. So your fx2, x1 is coming from this one. It's coming from this. So it's going to be 0.2027325 minus x1, x0 is this one, yep. 0.46298 divided by the point x2 minus x0. So x2 is 6. x2 is 6. x0 is 1. So it's going to be 6 minus 1. So it's going to be 6 minus 1. So when you solve this, you need to get something like minus 0.051871. Now you have successfully obtained your second divided differences. So what's next? What's next is that you need to plug into this formula here. Okay, so when you plug into the formula, okay, you will get f2x equal to your fx naught is 0, okay, plus x minus x naught. Your x naught is 1. Alright, your first divided differences is here, is this one, 0.462098. Now next is x minus x naught is 1. Then multiply by x minus 4. And again, multiply by the second divided differences. The first row, always take the first row, yeah. The first row here, so it's going to be minus 0.0518731. Okay. So with that, you can evaluate ln 3 by simply replacing your x equal to 3. So you will get 0 is 0 plus, so this one is 3 minus 1. I'll just copy this one here. So it's going to be 3 minus 1. So this one is 3 minus 4. Multiplied by minus 0.0518731. Therefore, at the end, you will get 1.027942. So this is the approximation for ln 3. Okay?